Welcome everyone, and thanks for joining. Thanks for you, Stéphane. I will introduce in a few seconds. So today we are going to demystify AKS. So with you, Stéphane, and we are going to do it in two phases. So zooming out, then zooming in, going deep as we can, from architecture to implementation, operations, and scale. Because most of production issues start earlier in the process, at the decision phase, and as engineers, we have a lot of decisions to make about the landing zones, cluster models, isolation, networking, and so on and so forth. So for that, we have Stéphane with us, who is one of the best cloud architects on AKS that I personally know. So he is a senior cloud and cloud native architect, Microsoft MVP. What I like the most about you, Stéphane, when I talk about you, it's you are very hands-on. You have been building infrastructure like for 20 years now, 26 years now, more or less. And also, it's important in our discussion is the large scale that we have seen in sectors that are sensitive to security, governance, like banking and so on. So that's a very important point. And you are also an author. You have written mainly on Azure, as far as I know. I'm sure there are a lot of things that you may complete, so I'll let you complete the intro, and then we can get started on the technical side.
Yeah, thanks, Shafiq, and thanks for having me today. So yes, today, indeed, we're gonna basically zoom out first, right? So see a bit the big picture, and then zoom in a bit more inside, internals of the cluster, and so choices you need to do. And then indeed. So just a little bit of advertising. So indeed, I just wrote a book. It was published in December 2025. So last year, a few months ago. It's called the Azure Cloud Native Architecture Map Book, and inside the book there is a dedicated chapter on AKS. So a lot of the things that we'll present today are also covered in the book with some hands-on examples and so on. So so I propose that we get started. So I'm gonna share, I have some supporting materials, so I will share my screen and show, let's say, some of the, I'm already sharing my screen, sorry. So let me see if I take, let's say, a browser. You should actually see at some point.
So we'll be starting with the zoom out, like understanding the big picture about AKS, Kubernetes clusters in Azure, their landing zones and all the basics, and then we'll be going deep inside, right?
Indeed. So do you see my screen here? I see some virtual networks, spokes, and so on, or not? Just to make sure.
Not yet.
Okay, then what I'll do is maybe stop sharing and reshare, because I guess I was already in sharing mode. Sorry, guys, bear with me.
Yes.
And I will try not to accidentally leave the meeting. So let me stop sharing and then come back. Okay, stop sharing, and then I reshare again. So let's try. And then let me see, this is the window. Gotta take this one. It's very small, so or can I just take the entire screen? Entire screen. Okay, I'll just take the screen. It's gonna be easier. Okay, then you should actually now see some VNets, right?
Yes. So yeah. I'm gonna do the devil's advocate today, like to really squeeze the max I can to get like the maximum insight. So as an engineer, starting with AKS, so what should I know at the basic level when I get started?
Yeah, actually, when you get started, you should first know that AKS is not a service like another, right? It's a universe within the Azure universe. And so that's why it's important to first zoom out, understand where you basically put AKS, right? How you deploy it, but where you deploy it. And that's why I'm showing you here this like picture. That's kind of very basic setup, but it's what is called the hub and spoke topology. And so the hub and spoke topology is something that, let's say, is intended to basically isolate apps, right? So into virtual networks. And so basically here we have a very basic setup with like a hub in the middle, and then we have 2 spokes. Of course, in reality, you might have hundreds of spokes, if not thousands. And the goal is typically, you see that it's mainly, if it's widely adopted, is that in the spoke, you would typically have one application. In some companies, you might have more than one application. That's already important to understand what's the DNA, what is appetite, so security in terms of segmentation, how do you segregate apps. But you see that now Microsoft also published a few years ago something called the subscription democratization approach, which in a nutshell is like you create one dedicated subscription and one spoke, of course, per application, per environment. And so that's like kind of maximum segregation. So there are downsides and let's say pros and cons of this approach. But typically what you see is that security teams feel very comfortable if you say one app per spoke, right? Because it means that everything that is entering the virtual network or exiting the virtual network has to go through a hub. And then that hub, of course, as you can guess, you have a next-gen firewall. So if you take the Azure native offering, that's Azure Firewall. Of course, you could have like third-party products like Palo Alto, Checkpoint, Fortinet, and so on. It doesn't matter too much, although it's often also subject to debate. But let's say the principle is that everything that's going inside and outside of the network of the VNet, let's say, is going through a firewall, a next-gen firewall. And then it's also widely admitted that the intra-application traffic is only controlled with Azure native constructs like network security groups. See, that's the icon you see here. So whatever you put inside, not whatever you put inside, that's why it's important to think about this. So what that means is that east-west traffic, so if you have application-to-application traffic, spoke-to-spoke, you have the guarantee it's going through a firewall, right? Because it's technically even required, because those 2 spokes, right, are both peered using the VNet peering to the hub. But VNet peering in Azure is not transitive. So it's not because this one and this one are peered to this hub that they can talk directly to each other, right? So you need something in between, okay? Feel free to interrupt me, Shafiq, at any point in time.
No, it makes sense for like I'm trying to understand from the big picture, like especially this is like in terms of landing zone, I have the hub and spoke and so on, and trying to understand how I can create a cluster that I make, especially at the enterprise setup. In an enterprise setup, there are a lot of criteria. So trying to follow your flow, and it makes sense till now. Yeah.
And so, okay, say that you have this topology, hub and spoke, and that you work with the principle of one app per spoke. Then it means that if you put an AKS cluster in between, it means that typically AKS, Kubernetes in general, OpenShift, the same, is often not for a single application, right? So it's often, you create a cluster and you're going to have more than one application in the cluster. So if you do this, then it means that you already kind of break, it's a game changer. You break a bit the hub and spoke model, because here you had the guarantee that when you have up-to-up traffic, it's going to the hub and the firewall. Whereas in the cluster, then of course, it would be kind of relying on logical isolation, right? But we'll see that there are other means, but let's say natively, it's going to be logical isolation, right? So meaning network policies, service meshes, combination of both. But then it also means that your organization needs to be ready to embrace cloud native things. So what I see now more and more, I would have thought it to be crazy like 5 years ago, but not anymore, is that if an organization is driven to really secure the workloads this way, that actually you see more and more organizations talking about dedicated clusters. So in the cloud, right, in Azure at least, we have the possibility to work with dedicated clusters, right? Creating an AKS cluster, it's not so much of a big deal. It's all infrastructure as code, you just deploy it and that's it. And so you might say that if you have a dedicated cluster, so a single application per cluster, you just push it into VNet, right, of that application, then somehow you're still in line with your intended use of the hub and spoke. Again, if that's taking as a principle that you want to have one app only per spoke, right? Again,
so in this case, this case, when you talk about the dedicated cluster, should I understand that the dedicated cluster is in the spoke? Like every spoke has its own cluster?
Indeed.
Versus the shared cluster, which means I have one in the hub.
And
Not in the hub.
No, never.
Yes.
Right? So in the hub and spoke, the hub is only to, let's say, accommodate system functions like firewalls, like DNS, like, so kind of, if you would put an AKS cluster in the hub, that would not be for to host applications. It could be for IT, right? Say that you have CI/CD agents, right? Because they need to be able to deploy to the spokes. They need connectivity to every spoke, so that would make sense. But putting an application in the hub, it's an anti-pattern for the hub and spoke.
You know, I have. Let me show you like the setup I usually have, and I would love your insight about like what makes sense.
Stop sharing it. Oh, you're sharing it. Good.
Yeah. So for example, I have this is like my simple architecture where I have my ECAS cluster here, and the goal I'm building with Terraform. So I build with IAC because the goal here is really to deploy this infrastructure, not just from the high level. And so, and here I have my cluster, and I have the hub and spoke model that you were explaining. So I have my hub here, and I have my spoke here. So the first question, as I'm building the cluster, where this cluster sits?
Well, see here that AKS is in the spoke, right? So if I see the spoke on the right of the screen, then AKS is in the spoke. So that's good, not in the hub. But you have actually I see like VNet and I see AKS VNet. So, and then, but the AKS icon is in the pink block. so you see, so in any case, AKS can only be deployed to a VNet, right? So either it's like what's called the managed VNet from Microsoft, either you do bring your own VNet, right? But at the end of the day, it's in the VNet and cannot span a VNet, right? So,
all right. Yeah. And in the discussion about the shared versus dedicated, so this is so when we talk about the dedicated, is clear that I have in every spoke I have a cluster. So how the shared works, for example,
that's the thing. So if you want to do shared clusters, it means that you will have to consider your VNet as then broader than just the scope of one application. No matter how you rule then traffic and so on across applications, somehow you have kind of another hub and spoke within the hub and spoke. You see what I mean? From a principal standpoint, because then it's not anymore one hub per VNet, because as I said, a cluster cannot span a VNet. So in any case, today, if you have a shared cluster, you can have multiple subnets, but you cannot have more than one VNet. So somehow you will have to live with that, right? And accept that.
So in this case, in my case here, I'm going to move this AKS inside the VNet to visually make it like here. Yeah. And then, and so where the logic, this is in the shared, right? And so in this case, how the older applications are hosted on the cluster itself? Is it different subnets?
Yeah. So I know, but that's the thing. So you have multiple options. I can also share stuff. So by default, if you have like in AKS, you have node pools, right? So, and node pools are a set of nodes, as the name indicates. So we typically use different node pools, one dedicated for system node pool, that's kind of a best practice. And then you have at least one node pool for what is called a user node, okay? So that is, let's say in the user node pool, either you have one or more. And then you can also map a node pool to a subnet, right? So you could divide and so can kind of have layers, but I will show something for landing zones, right? Okay. And then the way, so it's not scalable to have like, say that you have a shared cluster, it's kind of a multi-tenant cluster, right? Because you have multiple internal tenants or external tenants, right? And so it's not scalable to say you have one subnet per tenant, because then of course it's somehow having like one VNet with 200 subnets doesn't make sense. So you kind of balance this. So it means that at some point, if you go with shared clusters, you will have to at some point accept some logical isolation, right? So not only rely on pure Azure VNet stuff. So, but maybe before I zoom in really into the details, let me just first go share again. Do you still see my screen? Yes, no, because you took over. I'll stop sharing and restart so that you see my screen or not?
Not yet. Not yet.
Stop sharing, and I will share again. Okay, so that you see, because it was still telling me that I was sharing, so I was a bit confused there. So entire screen, so I'm gonna take this one. Okay, so if I see, you should see, let's say some slides, right? So still quickly, pros and cons of dedicated clusters. So actually you minimize if you have a dedicated cluster, again, it's then one app only per cluster, and then that cluster in the spoke, then you minimize the blast radius, right? So in security-driven organizations like financial, insurance, and so on, or highly regulated pharma and so on, they might like the model because somehow they know that if something happens to the applications, could be cyber attack, could be any kind of outage, right? Somehow the blast radius is limited because it's only one app that's impacted at the time. So somehow it's also easier in terms of operating model. I'm not talking about operational overhead, but more the fact that, okay, it's your cluster, guys. So if you want to delegate more to the application teams and so on, you could, because again, worst case, they break something, they only break something to their own application, right? It's not impacting the others. So easy for chargeback, right? So if you need to charge back the cost of cluster, it's easier in the dedicated cluster mode than, of course, in the shared cluster, where you will need to really understand who consumes what, and then be able to, let's say, create billing reports based on that.
Makes sense. Yeah.
Natural fit. Yeah, you want to say something, Shafiq?
No, I said it makes sense in terms of the cost, because this is one also of the biggest topics when we talk about the dedicated clusters.
Indeed. So natural fit with hub and spoke, again, if you intend to use a hub and spoke with one upper spoke, so that's then it's natural fit in this case. So it's aligned with the subscription democratization concept I explained just earlier. And then it's also, you don't need to mitigate the noisy neighbor effect. You don't have it anymore, right? By design, it mitigates because, of course, you're the only one consuming your own cluster. So if at some point you have compute, shorten compute and so on, or if you increase the compute, then it's because you need it, right? You cannot say, yeah, it's my neighbor that actually is consuming more than me. No, it's for you, right? So on the cons, of course, you have a cost overhead, right? Because system node pool, that's something that's mandatory per cluster, right? If you want to be highly available, and that's, of course, the best practice in production, you would likely use the 3 availability zones per region. Most regions have availability zones, so meaning 3 nodes, right? System nodes, the skew, so the size of virtual machines of the node pool for system node pool is not huge, right? Typically, it's okay, especially if it's dedicated, and you're not gonna have hundreds of thousands of pods, unless it's very big application. So unlikely. So could still be okay, but then you can consider the overhead of the system node pool to be about 600 euros a month. Okay, that's what you would pay. Again, might look a lot for some. In the financial industry, it's peanuts. Okay, they don't even consider this, right? It's not an issue. Control plane, so that's API server with SLA. If you want to have an API server big with SLA, you have a small cost. It's not a big deal. What I think would be potentially actually impacting even more the cost is the log ingestion. Okay, because then it means that you're gonna have some redundancy across clusters, right? They will each log the same information. Like you need to fine tune, but by default they would even take the audits and so on. That's a lot of logs. So you need to make sure that you fine tune a bit the logs to make sure you don't have too noisy clusters, let's say. Then of course you have potential lower pod density, right? Because again, if you want to adhere to best practices, even your worker nodes, you would also, let's say, distribute them across availability zones, meaning at least 3 nodes. Right, so if it's to build for a hello world application, then 3 nodes, right? Maybe for 2-3 pods. That's then you will waste some compute, and then so waste of money, and of course it's also not green, right? If you want to build sustainable systems, eco-friendly systems, that's definitely not the best usage. Then of course it's also harder to be consistent across clusters. Right, because then if you say 1 app per cluster and you have 100 hubs, and you have 100 clusters, right, in production, and then of course in the other environments as well. So then you still need to align those clusters. Then there are tools like Fleet Manager to kind of have a cross-cluster view, cross-cluster policies, cross-cluster upgrades, and so on, so that you start to have still a consistency. Right? Otherwise, but still it's harder than with a shared cluster. Of course, it's also not cloud native. You might live with it, and cloud native use of Kubernetes or OpenShift is to work with shared clusters. That's that's why it was designed for initially, right? Mm-hmm. But some companies say, okay, I know my blast radius, my boundaries are more important than being cloud native. Okay, and then I'll switch to the next slide. So then, if you would go then for shared clusters, and I think I have a glitch in the ignore please this one. So then the shared clusters on the pro side, so let's say the left side, of course you have economies of scale, so it's of course the opposite of the dedicated cluster. So then you need to adhere to a more cloud-native approach. It's an advantage, but it's also somehow for some organizations a challenge, right? That's why I also put in the accounts, because depending on the DNA of the organization you are working with, it can be kind of a showstopper. Some are not able to adapt. That's it. And so then, of course, you have a higher resource efficiency. If you have shared clusters, you have centralized governance by default, right? Because then you have only one, if you use Gatekeeper, AKS is using Gatekeeper as the policy enforcement, right? So the OPA agent. And so you take your Azure policies, you apply that to your cluster, and then you're sure that, okay, all the workloads deployed to that cluster are, of course, following the same policies, right? So in a centralized way. And then, of course, the RBACs, role-based access control, network policies, and so on. It's all ruled in the same way, right? Then from a governance standpoint, you have some kind of consistency by design. Of course, you also have, because that's also an important one, performance benefits, right? If you have one app per cluster, that's what the security teams like. Not everywhere, but what I can see on the field. But of course, if you have up-to-app traffic, then you have to go to a firewall. So meaning that, of course, it has a performance hit. If you have all the, let's say, apps, not all, but let's say some ecosystems within the same shared cluster, if you have up-to-app traffic and you accept logic isolation, then of course they're going to be more performant, right? Because they're in the same cluster. So the round trips from one app to another will be more performant. So for of course, if it's all in Azure, all in the same region, right, you will not have a huge performance difference. But for very low latency apps, that really need to be highly performant, then it might be better to regroup them, right? And of course, security is only one of the what I call quality attributes, right? One of the drivers. So you also need to see what are, what is your business? What does your business need, right? Is that highly performant apps? Is that high? That of course has an impact. So then, of course, the potential higher blast radius. That's for shared clusters, as I said. Okay, if you have cyber attack, lateral movements might be easier. And by the way, guys, just think we'll dive more in details just after. Always keep in mind that logical isolation, so network policy, service mesh, and so on, only apply to the container world. So if you manage to escape the container world to be on the node level, then of course you have lateral movements, right? You have ways to harden this. I will explain this, but still, so okay, and then these kind of container escape already took place in the past. So you have to keep that in mind and still try to harden it. So of course, then in this case, it's hard to calculate chargeback. Of course, makes sense. And then you need to control the noisy neighbors, right? Because you might indeed have, especially if you start sharing even node pools, right? Then you see you don't especially know who consumes what. Of course, you have the limits, resource limits, and that you declare at pod level and so on. But still, it's not that easy. Or namespace quotas. Yeah, there are ways to manage this, but yeah, it's more difficult than, of course, dedicated cluster where you have nothing of that to do. Basically, you just say, okay, it's your cluster, you need more. We scale and then you just pay for what you ask, what you have. And so, of course, this one, the shared cluster, is then not aligned with subscription democratization, where you apply this for one app per subscription per spoke, right? So that's a bit the pros and cons of, let's say, shared versus dedicated. Shafiq, before I dive into the landing zones, any question, remark, observation?
No, it makes sense. So maybe it's better though. Now we go a little bit in details in terms of, okay, like we peel the onion. This is the first like layer, the overview. We understand the big picture, and now if we go a little bit deeper, like because I always keep like in a part of my head the implementation. Like, what's the takeaway that I really implement in my life, in my current job, to create a cluster in the best way possible? So now if we zoom a little bit in to understand maybe the networking, I don't know if this is like the first thing that we need to start with.
I think it's good. So because indeed you have like when you deploy AKS, you need to choose the CNI, right? So historically, you could use kubenet. That's deprecated now. So I suppose that none of you still has kubenet clusters. So let's say we can forget about this one. And then we have Azure CNI, we have CNI Overlay, and then we have Azure CNI and CNI Overlay powered by Cilium. And then we have bring your own CNI. So before you choose something, you need to consider two aspects. One is supportability, right? So if you take bring your own CNI, great, but then you will not be supported by Microsoft. So then you need to make sure, if support is important for your company, you need to make sure that you have the support contract with the provider, right?
Stéphane, I have maybe a naive question, or newbie question. What's the difference between Kubernetes networking and Azure networking? And is there any overlap? Are they different? Are they complementary? Help me understand this layer.
No, yeah, indeed. So you know that in the CNI, it's container network interface, right? So any provider can just bring, providing you comply to the container network interface, can bring its own CNI, right? So what you have in Azure CNI, so let's spark Cilium. Azure CNI, so alone, means that the pods of the cluster will have real IPs from Azure, right? So a bit like when you have VMs, right? So if you have like 10 pods running on the node, the 10 pods will have an IP that is known by Azure. So meaning if you apply routing, what's called UDR, so user-defined routes, or whatever, NSG policy, security rules, and so on, Azure will be aware of those pod IPs, right?
So that's this is Azure part, managed by Azure completely.
Yeah, managed by Azure, because, yeah, indeed, completely managed by Azure. It's actually, the cluster is fully part of the Azure network.
Okay.
If you take kubenet initially, was not. Okay, kubenet, that was the default built-in, let's say, network system of Kubernetes. And then in Azure initially, they were basically adding some route tables and user-defined routes to actually have node-to-node traffic. It was managed by Microsoft, but still a bit complex. And that was like netted. Okay, so when you get pod IP, it's called IP masquerade. So basically, a pod IP is not known, right, and it's mapped to a node IP. So when the pod is talking to something else, the target would see, if it's outside the cluster, would see the node IP, not the pod IP. Okay, with Azure CNI, you always see the pod IP, whether it's a pod talking to another pod, or the pod talking to outside of the cluster, or from outside you want to talk to inside of the cluster. It's always the pod IP that you see. And then with CNI Overlay, it's an overlay network, so meaning, again, the IP, so concretely the pod siders are not known by Azure. Okay, so that's really important, because depending on how you plan to rule your cluster, the CNI provider really is key. There are other considerations. Azure CNI also allows you to work with virtual nodes. That's the only, let's say, option that offers this. So virtual nodes, virtual kubelets, basically. So that translates into ACIs in Azure Container Instances. So when you have like kind of bring a serverless flavor to your cluster, then you use this. There are some limitations into the CNI, into the usage of ACIs, but at least it brings a lot of compute power to your, let's say, cluster, and that is kind of serverless, only used when you need it. Okay.
So this is why troubleshooting the networking, it's sometimes a headache, like to filter which is which first.
Yeah. Not sometimes, it's always a headache.
Yeah.
So, no. Honestly, that's one of the hardest part. And so, even in Azure, by the way. But if you add Kubernetes on top, then indeed, network is not a trivial thing. And still, CNI, you have this, but then there is one big game changer if you choose CNI, is that it's also one IP per pod. So network teams typically don't like it too much, because it means that they need to give you a lot of IPs. Okay, so you see, then the size of your spoke will be bigger, right? Because if you really intend to have like thousands of pods in a cluster, it means that they need to free up thousands of IPs. That's the advantage of a CNI overlay, and that was also with kubenet, is that since the pod IPs are not real IPs from Azure, then you can have a very small VNet, right, and host a lot of pods. Because in the end, so that's of course often, especially in the IPv4, so some large organizations, they tend to be more and more reluctant to give you broad ranges. Okay, so that's one battle that I see almost everywhere. Okay, so they want to spare IPs and so on. So Azure CNI is not well seen from that perspective. But again, so the only way to have real IPs and use Azure, let's say, rule a Kubernetes cluster almost like you rule Azure is CNI. Any other option means that you need to really more rely on logical isolation, which was what Kubernetes was built for initially.
And now I bring another like a layer of complexity maybe. This is at the networking layer. So, and how my application will use this networking either to talk to another application within the same cluster or outside the cluster, or talk to the outside world in ingress and egress way.
That I can share some bits. So by default, and now I will now zoom in the but before I zoom in, so by default, if you deploy an AKS cluster, if you really take the vanilla stuff, it's actually not the most secure, because actually it means that you have a load balancer, right? That is public, internet facing. In the enterprise world, never do that, right? I mean, you should not do that. And so, but then it's used, it can be used for ingress, but also for egress. So if you have an outbound, let's say something going to internet, then it would use that load balancer. But for the application, it's kind of seamless, invisible, right? Because the application will just work with FUDNs, fully qualified domain name. So, okay, then you say, okay, I want to talk to google.be or google.com. Yeah, fine. You have a public IP back. And then you have internet, let's say, traffic available out of the box. So, but in the enterprise grade solution, you would not do that, right? So what you do is typically the minimum in a dedicated cluster mode, you might say, okay, you just route it to a firewall, right? That will then potentially even inspect the traffic, right? Before it goes out for DLP, so data leak prevention. Or you just say, okay, you not go independently of the TLS, right? But you never say, okay, the cluster can just speak freely to the internet, right? That's not really a good practice. And of course, even less for inbound, right? So let me share now, let's say, what type of landing zones you could have. Okay, so share screen. And so let's take this one. I think that's the right one. Wait, you should see Visio. I didn't take the right one. So do you see my Visio here?
Yes, this one.
Good. Okay, I will zoom in a bit. So you see a tab called infrastructure, right? So I will, let's say, before we zoom into more details, I still show a bit here. The big blocks, right? So say that I have like my cluster here. So in an AKS spoke, right? So, and here I'm more in the shared cluster mode. Okay, so not dedicated, although the principle of ingress and so on could remain the same. But here, as of now, I'm only talking about the shared clusters. Okay, so what you would have to do is that your cluster, as I said, cannot span VNet. So anyway, you will have to deploy your cluster in a VNet. And so it's a good practice to isolate still the ingress into an ingress node pool. Egress, I will talk about this later, but it's potentially a good option as well. And then you have the user node pool where you really have the application, so application pods that will run. So these ones, you can consider that kind of a system, right? Something where you will enforce the scheduler to make sure that it does not schedule any application pod into this one, nor into this one, right? These ones are like landing zone kind of node pools. And you also then map your node pools to subnet. You can do that. So I will, of course, not go through all the YAML and so on or hand charts that you have to go. But trust me, you can do that. And then, of course, you have the system node pool, as I explained before, which is, of course, restricted to system nodes only, right? So all kube system and so on. And so from an ingress standpoint, if you take, okay, traffic comes from internet, right? But it depends as well, of course, if you are multi-region, single region. So typically, if you're multi-region, you will need something like front door or let's say Cloudflare, right? And if you want to be robust, because you might have heard about a front door outage kind of a while ago. And so you can even also include Traffic Manager to the mix to actually have front door or rely on something else in case of front door has an issue, right? Front door is a global service. And so, but even if you don't have a regional issue, you might have a service level issue. And then if it's a global service, too bad, then you have a problem, right? So if you really want to go extremely resilient, you can go to these kind of things, but that becomes a bit, of course, more complex and more costly. That's something from the online doc. Okay, so say that whatever you take, so let's take the easy scenario, single region. All right, then it's internet coming to your application gateway in this case, and you of course enforce WAF policies, so web application firewalls. That's the bare minimum you have to do. So whether you use APIs or not, you might use API management. It's not mandatory, but it's a good practice as well to have a gateway, to really enforce some policies at this level. So before it goes further, and then you will always have normally a firewall, right? Whether so because a WAF is layer 7, firewall is layer 3 to 7, depending a bit on the firewall you take. So then, and then only after these layers, then your let's say the client, the internet client will then reach your ILB, so internal load balancer, which will actually be a backend of your application gateway in this case, right? And so, and then you're gonna have ingress controllers, right? So, and I, on my side, now recommend to use Istio. Why? Because Istio, you can do all with it, right? You're not forced to do all with it, but you can do all with it. And now it's also supported by Microsoft. Okay, so again, if supportability is something very important for you, then try to stick to the managed add-ons and extensions. Okay, so everything that you use from the managed add-ons and extensions is fully supported by Microsoft, which does not mean that you have the full-blown product. So Istio, the add-on is not as full-featured as the full-blown Istio that you will install yourself. But if you install Istio yourself, then you lose support from Microsoft. So you see that.
Just a quick question here in terms of service mesh. So you mentioned Istio. What are the other options that I have, for example?
Oh, service mesh, but you have Cilium, but Cilium, I would not use that for production today, okay? Because actually MTLS is still even announced in beta mode, and Cilium had, okay, they fixed it in the meantime, but let's say a year ago, they even had a security flow in the MTLS, okay? So when you basically, you know, when you have the service mesh, you basically have the basic, the bare minimums to enforce MTLS between the pods that are part of the mesh. Then you can even go further and say, okay, you want to enforce granular authorizations, like, okay, pod A can talk to pod B, but not to pod C, right? That was actually, they had a security flow in let's say, Cilium, where actually you could define authorizations, but they were relying on pod IPs. And as you know, pod IPs are very volatile. They are cached in memory of the node. And so the way also our eBPF works, and basically somehow some IPs were reallocated to other pods, and then the permissions were also assigned to the new pods, but that was not intended, right? So there was a real flow, and that was published also how to, let's say, exploit this vulnerability. So now they fixed it, but still the MTLS is considered like beta right now. So I would not use that for service mesh. Yeah? For network policies and so on, it's different, but for service mesh, I think Istio, it's the most complex, but you're not forced to use all, right? So if you just say you use it for MTLS, for ingress, egress, that starts to increase in complexity. I will explain where it makes sense.
Okay.
So ingress at least and MTLS, you know, the ingress controls of Istio are not that hard. It's very stable, okay? So I would say, and it's one of the add-ons, right? Other options that you had, of course, that you have is like for ingress at least, of course, it's like traffic. It's you know, depending a bit. It was more microservices kind of designed for Nginx, of course, historically. So you also have now to think about everything that is compatible with the gateway API, because as you might know, Kubernetes stopped the. Let's say it's deprecated now the ingress API of Kubernetes. So you need to make sure that your ingress controllers, even if you keep calling them ingress controllers, it's still ingress traffic anyway, are compatible with the gateway API of Kubernetes. So Istio is also, you see, so you have a lot of advantages of using Istio, and if you only use it for ingress and MTLS, good enough. Honestly, complexity is not that big there.
Okay.
So, and then, okay, that's the landing zone, right? So you would have like your application 1, application 2, application 3, then I'll dive even more into details, and then egress is only, so say that I'm using CNI Overlay, right? If I'm using CNI Overlay, as I told you, a pod here that would run in application 2, for instance, would basically, when it's calling something outside the cluster, you would not see the pod IP because it's an overlay. So you would see a node IP. If you regroup all the nodes into a user node pool, then of course that's going to be an IP of one of the VMs there. But you don't know if it's a VM for application A or 2 or 3, meaning that what is outside the cluster doesn't know which application is called. So either you say, okay, you rule completely that from within Kubernetes itself, and then you say only the ingress node pool is allowed to go outside, and you make sure that you by design, lock down, egress policies and so on. So make sure that you need to explicitly allow this. We'll come to that a bit later. Either you blind into, you just know that the cluster is calling. So in a dedicated cluster mode, that's fine because you know the cluster is for this app. So you know what app is trying to access what. In a shared cluster mode with CNI Overlay, you don't know, right? So with Azure CNI, you could know if you would say, or even with CNI Overlay, you could know if you had like one node pool per application, but again, it's not scalable. So doing this is certainly not the most appropriate.
And the egress and the rules that you define, who is allowed to talk to what? Is it at the NSG level or no, different?
It's a combination of network policies and service mesh, so Istio. But I will come to that a bit in a minute. So I'll zoom first, and then I'll come more to the, really, you see, I have like a Calico and some
Oh,
Istio.
yes.
Yeah, okay. So that's a bit the big stuff. And here, important stuff still, it's one ingress controller and one egress controller per application. So that is actually the landing zone. Okay, and so you make sure that they are co-located in the same cluster, but they have their own dedicated components. The advantage of this is that you can again delegate more to application teams without interference. So interference, I mean, if you have one ingress controllers and two applications deploying conflicting rules on the same, you might have an impact. If they each have their own ingress controller and egress controller, they are kind of in their own stack, so they cannot interfere with each other. Yes, you waste a bit of compute. Right? Because of course all these needs to run, you need compute for this. But then again, it's a question of how far you want to go into your landing zone, how far you want to share, and what kind of the cost friction or cost, let's say, additional cost you are willing to accept or not. And in any case, whatever you do, and that's I would say for dedicated clusters as well, as I said, typically you route external traffic to a firewall. Right? So Microsoft did something called static egress IP for public traffic. I have no clue why they did that, because I don't know any company that is not running or routing traffic, let's say, destined to internet or internet-bound traffic to a firewall. So, but okay. So anyway, they did it. So if you have like the public IPs, so you can, so with static egress IPs, you can define, let's say, one IP per. So to say, okay, traffic should actually go to that IP, right, or pool of IPs before it goes to internet. But again, typically you have a firewall somewhere, or even sometimes more like Netscope and so on, which is even harder. But okay, that's not so common. So now if I zoom in a bit in the landing zones themselves, okay, so I try to zoom in a bit. So that, of course, this is, so I parked the WAF part and so on. So here's the load balancer. Then you see here for a landing zone that you see here, application one landing zone, application one landing zone, application namespaces. Then you would have like the ingress part, the namespace of the application itself, could be one or more, right? And then you have the egress, right? And so for each of this, you would basically say, okay, you specify an IP. So you say, okay, I want to have my own IP for my ingress controller on my load balancer. It's the same load balancer, and that you cannot change. But at least you can say, okay, this landing zone, the entry point is this IP, right? And so when from outside, then you know that, okay, this is going to be this IP. Here, of course, you're going to replicate this. You have also, if you want to control and stay in a certain line, you will have to define an external traffic policy to local. Okay, so you should know that by default, ingress controllers come with external traffic policy to cluster, which means that, and I wrote plenty of articles on it. If you Google my name AKS, you will find plenty of stuff with really low-level details. But the cluster policy is actually, it means when you have the cluster, let's say a setting, it means that every node of the cluster can play a role in the ingress traffic. Okay, so even if there is no ingress controller running on that node, it can still play a role in the ingress traffic. So if you say, no, I want to control the entry point, right? I want to make sure that when the ingress controller of this application is like gold for something, then I want to make sure that it's only this node, let's say, that has this ingress controller running that can tackle the ingress traffic. So, and then of course that's, you have to do this. And then the other benefit I would say of doing this is that it's also then you still see the caller IP. If you use a cluster, it's doing a static, so it hides the source IP. So you don't know who is the caller anymore.
Okay.
And then something to say? Shafiq?
No, I'm following. It's super interesting to go like
And then
this deep.
Namespace where you would have one or more. And so typically then, of course, what you try to do is to say, okay, of course, you enforce MTLS. Again, that could be Istio. You can use any mesh, but what I like with Istio is that you can do all, right, with the same solution. So if you say, I take traffic for ingress, and then I'm taking, I don't know, linkd for service mesh, and then yet something else, you can. But then you also have to manage multiple products, and again, no support. Right, so you have to think about this. At least no support from Microsoft. So you can always contract, of course, with companies that will offer support. And so then, of course, the goal would say here you will, of course, enforce network policies, right? That by default, and that I will maybe not be able to do to go here today. But I will show in my book. You don't need to buy it, but there is a repo with all samples available for free. Okay, so if we have time, I would just give you the URL of this repo where I show really concretely how you can do that. But basically here, the goal is, of course, to say within the landing zone, you allow, of course, traffic, right, with network policies. You would deny everything by global network policies, right, to make sure that by default you cannot do stuff. Platform teams would deploy your landing zone, so meaning a landing zone, an egress controller, your application namespaces, and then that's yours, right? And in each of these namespaces, you should be able to deploy some resources so that you have some autonomy, but of course, not everything. So MTLS, network policies, and then of course, you make sure that, of course, again, by default, a landing zone cannot talk to another. And so then you start to have, still, it's all logical isolation here. So still, you might have some CISO teams in some companies saying, first, they don't especially understand what you're saying. And secondly, of course, that's completely different from, again, the next-gen firewall in terms of which controls you can employ, you can enforce, but also in terms of how they see this. Because one of the challenges you have with, let's say, network policies and service mesh is observability. And there are tools. So if you take, for instance, Cilium for network policies, then you have Hubble. For Istio, you have plenty of dashboards and so on. But still, it's not integrated with the tools they typically use, right? If you take, for instance, Palo Alto, it has something called Panorama, and that's kind of the Bible for security teams. They just look at that, right? Or they do like AlgoSec, right? And say, okay, give me all your flows, boom, AlgoSec export, you have all at once. This escapes a bit this, right? So that's a bit more, that's one of the challenges you see in some companies. That's where sometimes you have some resistance. Of course, a startup or like, a mid-sized company, they would not even bother even with network policies and so on. They might just use the flat cluster by default. It's all open and good enough, and they don't care. It really depends on the company you work for. And then, so if we go a bit further down the line, then the egress, node pool, then it's only from this node pool and subnet then that you would accept traffic, let's say, destinations, whether it's like for private destinations, like, PaaS services with private endpoints. And you could say in the NSG level, you basically only accept traffic coming from the egress node pool and egress namespace, and you know that your service mesh and your network policies combined together will lock down traffic by default, so that if something is reaching out to this, right, to SQL, for instance, that it has been ruled, right? But then you need to trust the ruling, because here you just know, okay, that it's the egress node pool calling you, and then, okay, traffic was enforced to the egress gateway. That's the only thing you know from a PaaS service or from a firewall. Okay.
Makes sense.
Yeah. And so that's one thing. And then of course, you have like ecosystem solutions that you can use, of course, but that's more like for the application teams, Dapper and so on and so on. That depends. Kida, of course, to scale your pods. That's kind of, for me, Kida, Istio, Calico, that you can discuss. You have Calico, you have Cilium, and so on. Depends a bit what you prefer here. Maybe still something to show. Shafiq, is maybe the equivalent, but more from with an application eyes, right? Because that's really more infra views. But that's something that I propose for one customer, more with, okay, same principle of landing zones, but then you see a little bit, okay, how you could organize your applications within the shared cluster. And that is, for instance, using that customer is like following the principles of API-led connectivity. So for those who don't know, API connectivities, like you have different types of APIs, right? In the nutshell, experience APIs are behind. In fact, you have first a BFF, backend from front end, and then you would have your single page apps or whatever front ends in the front talking to your BFF. And then the backend for front end is actually doing some calls to other type of APIs. And typically what is directly serving the needs of a front end is called an experience API. That's in part from MuleSoft. So API connectivity is a concept created by MuleSoft. But even organizations not using MuleSoft are actually some adhere to these principles. Then you have like process APIs, where you have like a kind of aggregation, handling more complex tasks, let's say, that we not do that directly in an experience API. And then, of course, all the communication between those, most is actually doing it with queues, so that you can send comments to queues, and then process API can just dequeue stuff, process that, queue back to say it's done. And then you have like the system API, so this kind of a proxy in front of your data stores, typically, right? So if you go to a database, you would have a system API in front end. And so here, then of course you can also have like direct calls, although typically asynchronous communication is the most efficient, let's say, most scalable approach. But if you have direct calls like this, then you would also, of course, enforce MTLS here.
And a quick question, Stéphane, about this. When I see the network policies authorization, so where these are defined, at which level?
So you have two levels. So network policies, if you at least work with Calico, for instance, then you have global network policies, so applying to the cluster. Of course, from this, you can exclude some namespaces. So that's best practice. And that's in the repo I explained, so I will show the repo after. Global network policies are cluster-wide, right? But you can exclude some namespaces. So you would exclude, for instance, kube system, to make sure that cluster keeps working. Because if you say global network policies, egress, ingress, nothing, then the cluster stops working, right?
Yeah.
So that's the best way to break completely. So you have to pay attention to this. And then so by default in the global network policies, you will also then lock down everything except for some namespaces, which means that by default, again, this will also not be permitted, right? Cross-landing zone traffic. And then if you want to open up, then you will define network namespace scope network policies to actually rule out you have two levels. Either you do that in the namespace of the landing zone itself. Either you also can do some stuff at the level of the global, right? Because the global has a global view, so you can exclude or only include some namespaces, so you can play with this. And when I say namespace, labels, right? You can play on labels and put rules that are, let's say, that are applied based on the labels that are used by the namespace and so on. So here, you don't see it here, but basically what I do for the landing zone is that I label each namespace of my landing zone with a specific label, like LZ1, LZ2, LZ3. So then you say, okay, whenever, and that's what I say to CISO teams, if you see rules, as long as you always see like equals LZ1 or something like that, then you know that it remains within the app. If you see at some point it's going to LZ2, then okay, you might ask questions. Okay, why do you need this kind of talk to another let's say app? So two levels, and then service mesh, it's exactly the same. So if you see Istio, you have the Istio system namespace, right, where you can enforce the global stuff, and then you have also a namespace scoped resources. So that's to apply only a namespace that then only apply locally. So I can maybe show a bit. So because I only have 5 minutes left. So if I will not then go to the Dapper versus service mesh. We don't have time, but okay.
No, that's fine. I think we can, we can maybe take 10, 15 minutes more.
Because that's also something I keep hearing, all the times people completely confused. So I suppose you know Dapper, right? At least Dapper is a very well-known product, really good. So biggest difference between Dapper and service mesh is one, Dapper infuses the application code, right? So it's in the code. The service mesh is completely, the application is agnostic of the mesh. It doesn't know it's injected by a mesh. So you see, that's already a big difference. And then if you see here, that's like with Istio, but that applies with any service mesh. Here it's still with not the ambient mesh. It's still the sidecar-based mesh with Istio proxy here. And so here, if you inject an application with Istio, there is no way to bypass the Istio proxy. Why? Because Istio implements what is called the ambassador pattern. And so you cannot say pod will try to talk directly to application container. It's not possible, right? So it's like really filtered by Istio, no way to bypass. Of course, then you can say you ignore this or a lower block that you have, but then still governed by Istio. Which also means that if you have done MTLS, that a pod can only talk to another pod if it's authorized to do so. With Dapper, Dapper also supports MTLS, but with Dapper you can do this. So Dapper does not, the Dapper D container is not implementing the ambassador proxy, so it's not actually rewriting the IP rules, the IP tables of the pod. So it means that by default, if I say, okay, I have an application container, I actually can talk directly to another application container and bypass Dapper. And so then bypass the MTLS of Dapper. Because that's not the intention of Dapper. So Dapper, the service discovery, right, the invoke API, okay, will of course go Dapper D to Dapper D if you use the invoke endpoint. It's not like if you don't use it, then Dapper doesn't care. Dapper is even not involved, right? So then the only way to lock it down is, but then you have to pay attention, is to really lock it down to 127.0.0.1, right? So which corresponds to localhost. But if you put localhost in your application settings, localhost in the Kubernetes world translates to 0.0.0.0, meaning any network interface. So that's why you can actually do this. With Dapper, you cannot do that with a service mesh, whatever service mesh is. So just so that you see, there is no overlap features, but have to pay attention. And Dapper again infuse the application code. So if you need it for your application because it's a great framework, a great abstraction layer, then of course use it. If you say yes, I have MTLS, it's enforced by Dapper. No, you need then to make sure you lock traffic down to 127.0.0.1. Okay, else you are MTLS protected, but you're not. Yeah.
We have a quick question from Lalit. He asked for observability and troubleshooting of service mesh problems. What is used here? In the past, I found it a bit difficult to debug service mesh issues or issues like timeouts and so on.
Yeah. So basically, you have two levels. So observability, you have like dashboards in Istio. Okay, so you can use the dashboards to see, and then you have, it shows live the traffic and so on, the interaction between components. That's one of the things you can use, all the dashboards that come with it. And then, of course, for really configuration issues, so say that you are building something and doesn't work, you don't know, but you have the Istio CTL command line tool, which helps, let's say, find or see any misconfiguration, right? If you do that, you have like Istio CTL analyze, you have plenty of, let's say, flags that you can use with the command that help you understand where the problem is. But it is true that there is a certain level of complexity. But again, it depends on what you use. So if you use the egress gateway, then it's complex. If you just stick to ingress, let's say, and MTLS, and even basic MTLS, no like advanced authorizations and so on, honestly, then it's not that complex. You have to deal with, like I can show you, you can just deal with this, right? A few resources like the virtual service, the gateway, and destination. If you only use ingress, you use that, that's good enough. You don't need to know anything else. Authorization policy, you don't even need to know. You just enforce, let's say, the MTLS at the cluster level with a peer authentication. You say, okay, that it's strict mode, and then MTLS is enforced. So you at least have the guarantee that something that's not in the mesh cannot talk to something that is in the mesh. And that's already a good level of protection. And if you only do this, honestly, you don't need to learn much. And Istio, that's the advantage. I worked with several meshes in the past. Istio, it's not easy, but once it works, it works. I mean, it works. So of course you might have other stuff that are not linked to Istio. So, because of course it's not always easy to understand. Okay, if you have a network issue, is it the Istio sidecar that is a problem? Is it the firewall further down the street, right? That is causing the problem. That is indeed not easy. And I must admit that the Istio error messages are a bit cryptic. So if you look at the Istio logs, indeed, it's not the most verbose logs or the most. So, but of course you get used to it at some point. But I think what helps to troubleshoot is to, again, understand a bit the bigger picture. Because typically, again, if you have Istio inside of a cluster, you also have probably WAFs in front, firewalls in front, and maybe, and for sure, when you talk to outside of the cluster. So sometimes you might have issues, but are not actually because of Istio, just because something else further down the line, the data path is basically blocking traffic, right?
And one of the points that I had as well, and we discussed it last time, since we are talking about like the networking isolation and so on. So what's the difference between namespace isolation versus node pool isolation? Because
namespace is fully then logical isolation, right? So then you will use Istio, Calico, and so on. But as I said, it's only container level. If you have node pool isolation, I actually did not want to do this. So if you have node pool isolation, then you can, let's take again the infra view. Then you can, of course, map node pools to a subnet. And again, you then have to influence the scheduler to say, okay, use state tolerations to make sure that regular application pods are, let's say, not scheduled against the kind of system node pools. Of course, not the system node pool itself, nor ingress or egress, right? But then you can also enforce like network security groups, right? Because if you map a node pool to, let's say, a subnet, then, of course, all the IPs of the node pool of a given subnet will all, of course, have an IP from that subnet, right? So then you can say, for instance, here, I'm just saying, from the user node pool, I only, let's say, allow, in fact, you see even here, because I put the rules, in the ingress node pool, I only allow traffic to the Kubernetes system ports. That's required, otherwise you break Kubernetes, and the WAF, and that's it. And potentially other internal clients if you want them to bypass the WAF if they're already inside. But so that will work fine with Azure, right? If you put everything into the same subnet, then you're going to have a single NSG. Okay, fine, you could still put rules, but then it's going to be harder to, to have a more manageable stuff. So as I told you, if you escape the container world, then you are on the node. And so NSG, so if you say, I didn't put it here, but basically if you do this rule in every NSG of every subnet, already if you escape the container world, then the only ports that are still available are the Kubernetes ones. So there would also need then to have some vulnerabilities at Kubernetes level to be able to still have lateral movements across node pool. You see? So that's why having those 3 layers is one way. Now, if you would really say, for instance, and that's possible, I've documented all of that online in the GitHub repo. If, let's say, you would want to say, no, I want to rule everything to an next-gen firewall, because some companies don't want to do that. So then you would indeed either chunk into multiple subnets, but that's not the most scalable approach. But if you have like only a few tenants, that would still be okay. But then you cannot use CNI overlay. You would have to use Azure CNI. And then you can say from subnet to subnet, you route everything to a firewall, and that works fine, right? Either, and that's something that, of course, we don't have, we cannot tackle here. No, you have also solutions that are, like Palo Alto, for instance. They have the CN series, which actually are firewalls inside the clusters, right? So they hook to the CNI. And so they can also, then you can then put rules based on labels and so on. So then, of course, if you do this, you have like a next-gen firewall inside of your cluster. But of course, you have to balance costs. But that's, let's say, of course, pure security teams, they would love this one, of course, more than anything else. But again, it depends on what is the DNA of your, customer or organization. So because
that was my next question is about the cost implications, because all right, so we have a lot of options from using native Azure services to using maybe open source tools and make it our way, to use vendors like firewalls, Palo Alto, Checkpoint, Ping, and so on. So what are the cost implications like in the whole architecture?
Cost, I would say here, if you segregate already some node pools into subnets like here, but then you have cost of extra nodes, right? Because here, an ingress node pool means at least 3 nodes, right? Again, if you consider the high availability, then 3 zones at least. Same for egress.
This is at the cluster level, like the pure compute level. Okay.
So there you already have like 3 nodes, 6 nodes. Then that depends on the, let's say, number of apps you want to onboard, and then a minimum 3, of course. Again for availability, and then so you already have 9 nodes, and then you have the system node pool to 12 nodes. You see, so you start with a shared cluster of 12 nodes. If you say no, I don't care, I don't need to isolate. Okay, then you put You can even have one ingress controller for the whole stuff. To see, then of course it will consume less, and then replicas to still make it scale. It will overall consume probably less compute, and then you see. So the cost implications are, all these components need compute to run. So if you say no, I don't care, I mutualize ingress, egress, or I don't even use an egress controller, again, it's optional, it's not mandatory. Then you could say, okay, then you shrink it, and then you only have your system node pool, which that is really, I think it's even, I'm not 100% sure anymore, but I think you're not even supported by Microsoft if you don't segregate system node pool from the rest. So, so that's then you have the minimum cost of a cluster is like 3 nodes for the system node pool, or 2. You could say, okay, I stick to 2 OT zones, and that's good enough for me. And then at least 2 nodes for your workloads. And then if you want to mix everything to the same node, you can. So, but then of course, and then use the scaling, the auto scaling of the node pool. Say, okay, always minimum 2 nodes, and then you scale to whatever you want. So maximum 1,000 nodes. It's possible, right? And then it's a much simpler setup. But then, okay, the thing is that if you have 0 rules, 0 governance, and I've seen that as well, and that's the problem, is that clusters can become very messy very fast. Okay, and then you see that if you have clusters of 100 or 200 apps in the same cluster, 0 governance, then you have no clue about what's happening in the cluster. So,
yeah, that's exactly what I was about to ask. Is like when you scale, you will get at some point into picking the battle, like governance versus costs versus security versus maintenance and operation. So sometimes it's hard to find the right balance. So like, if you have to give an advice of someone who is building now, having the opportunity to think about it now, like what could be the best approach? Like, or maybe what should we optimize for from the beginning?
But for me, identify the key drivers of the company you work for. So if security is not like the #1 priority, then I would go to a simplified cluster. And then, for instance, I would then use node pool segregation only when you have different compute requirements, right? When you say, okay, in this I want to have like AI kind of things. In this I want to have like gen purpose kind of workloads. See, so that's, and then you maximize the auto scalability and so on, and then you would actually try to leverage economies of scale. You see, if security is not like the one of the main concerns, then don't bother too much. If security is one of the main concerns, then stick to at least this. And again, you have also the options to inject next-gen firewalls inside clusters. So then you need to see how far you want to go. So really, don't design just without knowing the external factors. That's the most important, right? Because if I would say, I'm designing something in the corner of my table, and I go to a customer and say, yeah, that's your design. They can say, it's overkill. Are you crazy? I will not pay for all of that just for your security because I don't care. Or the opposite, you virtualize everything into one node pool, everything, and all apps and then you go to a bank and then you say, that's my design. And you say, okay, go back, we don't need you anymore. You see, so you need to understand the industry you work in, see what is their appetite, and then what are the drivers. And then of course the hardest piece is, okay, if at some point you need to have both security and high performance and so on, then you have a trade-off. And then if you identify the trade-off, you need to document this design and then make sure the customer understands the decision they make. At least that's how I see my job. It's not like, if I say 3 options A, B, C, I say, okay, technically speaking, the 3 options are possible. The worst one is C, and the customer say, okay, I take C. Yeah, I would still sleep at night, although I don't sleep much. But it's not gonna be. I don't care. I made my job. I informed. They choose. That's it. You design decision, document it. Next.
Makes sense.
Yeah.
Stéphane, thank you very much for all the details. And I think this is, I personally maybe watch it again, the session to go to grasp all the details, especially like in the networking landing zone. This is important for someone who is taking decisions like maybe every day about what could be the best scenario possible. Thank you very much. And so the last thing that you want to share, like for all engineers building out there, I know that we have a lot of AI, but I don't believe AI. I mean, AI is great to use to build. To build maybe greenfield, but the knowledge at the personal individual level, for me at least, it's I believe it's not replaceable yet. Like to have all these criteria and scenario. So what could be like the last advice for engineers out there that are starting on AKS?
But maybe they can already go to my GitHub repo, so and see
Absolutely,
what's in there.
share the link. Yeah.
So if you just type GitHub Stéphane Eyskens, right, you have my name GitHub, and then you will find my repos. And then I have one repo called AKS Azure and AKS. Azure and Kubernetes architecture. And then you will find a lot of stuff. So on AKS, but also on plenty of other stuff in Azure. Could be one thing to understand a bit the trade-off. I also documented really all the options for CNI and so on. So you see some cheat sheet. I like cheat sheet, right? So that's a quick way of finding a bit your way and then try to see what are the factors to consider. And then of course, AI is great, but I think there are still some level of complexities that are not fully covered. So in any case, you should remain the driving seat, at least so far.
Exactly.
Might change in 5 years' time, but I would say so far I would not rely too much on AI. So you still need to understand a bit what comes out of it.
Exactly, the trade-offs and why, the reason why, because there are different branches in the decision process. Stéphane, thank you very much of making the time for the session today and for all the details. Enjoy the rest of your evening. And for everyone, thank you for joining us today. And this is part of the engineered sessions that we started by inviting experts going deep into a specific topic. And the next one will be in 2 weeks from now. So stay tuned and goodbye, everyone. Stéphane, good evening.
Thank you. Goodbye.
Thank you. Goodbye.